Hey, just some things on your questions. So let me just put a board up here for you. Okay, so with limits. Okay, basically you have to, all that you need is factoring skills and rationalization skills, which means using roots. Okay, so if we bring this over so we can see, I'm not going to do this one here. If you put a 2 in there, you get 8 plus 8, which is, or sorry, if you put a -2 in there, you get -8 plus 8, which is 0, over 0, which is an indeterminate thing. So that's not a limit. So you have to do a factoring. So you have to factor the top and the bottom. So when you're factoring this, this is a sum of cubes. So if we're doing something like that, I'll work this one similar with you here. Just let me grab my pen. There it is. Okay, so you get x plus 8 squared over x plus 2. So if you're trying to factor this, the formula for that is a plus b a squared minus 2, or sorry, not 2, minus ab plus b squared. And that's in the notes somewhere on how to factor a sum of cubes. So now, if we're looking at this as a cubed plus b cubed, okay, well, this would be, this is a cube, by the way. This would, a would be x, and then the cube of 8 would be 2. So this would be 2. So b would be 2, and a would be 1. So this would be x plus 2, x squared minus 2x plus, and then 2 squared is 4. And that's x plus 2. So once you get a common factor like this, cancel. Okay, now when you do it, you've got x squared minus 2x plus 4, and then you're taking the limit as you approach -2. You can put in a -2, and you won't get an indeterminate result. And I'll let you figure it out from there, okay? And you'll get a number. And that's what you do for all those types of questions. Now, looking at your question, let's move me out of the way here. Okay, so that would be, and then we'll take a look at, let me look at my list here. Yeah, so if you were to, you're looking at, you wanted to know when it's going to be discontinuous. Okay, so I'm going to do a different one. I won't do the exact one that you got. Okay, you've got this one that you were wondering about. Okay. So I'm going to just change the numbers to show you how it works. Root x. Let's do -2 instead. So let's say at 2. So if I put a 2 in there, it's going to be equal to 0 over 0. So test 1, first thing is sub in the 2. Okay, so sub in the 2. So this is yours, but I'm doing a similar one with just different numbers because I don't want to do the exact same answer. So I'm going to sub in the 2. So it's root 2 minus root 2 over 2 minus 2. 0 over 0. That means right now it fails. Okay. Now, test number 2 that you have to do to see if it's discontinuous or continuous is you have to take the limit of this as it approaches the number 2. Okay, now the way to do this is to factor the bottom as a difference of squares. So this is the same thing as, so we go root x minus root 2, and then we do the opposite of that, root x plus root 2. And that factors it, so this cancels it out. And we're going to get 1 over root x plus root 2. And if you put a 2 in there, you get 1 over root 2 plus root 2, which equals 1 over 2 root 2. Which if you rationalize by multiplying by root 2's, you get root 2 over 2 times 2, which is 4. Okay, that passes. Okay, and then the last check is to see that if they're equal. Does 1 equal 2? So 0 over 0 does not equal root 2 over 4. So this is a fail. So that's what you do to see if something's continuous. You plug the number in, then you take the limit, then you see if they're equal. And if any one of those 3 fail, it's discontinuous. Okay? What else did you ask me here? Okay, so okay, so what about rationalization? So let's do a rationalization example. Okay, so let's say that I have a limit of x approaches 0 of, let's go with x over 9 minus the root of x plus, well, let's not do 9, let's go 3 because that's a little big. Let's go 16. Let's go. Yeah, we'll go 16 here and 4 there. That'll work better. 9 will be a little too. Okay, so if I were to plug in the 0, I would get 0 over 4 minus the root of 0 plus 16 is 16, which is 0 over 0. Can't do it. So in order to get this by itself, what we got to do is we've got to rationalize this by multiplying the bottom by the conjugate form. So what we do is we go x, take the conjugate form, so change the sign of this. 4 plus x plus 16 okay, so then this, we multiply it by the same thing, but it's the opposite sign, you see. Okay, so don't do anything to the top, just leave it. Okay, and then this, whenever you have conjugate forms, it's the square of the first minus the square of the last. So the square of the first is 16 minus the square of x plus 16 is x plus 16. Okay, so that's going to give you x times 4 plus the root of x plus 16 over, in this case I get negative x. So I cancel out the x's. So that's going to be a negative 1 on the bottom. So then now I put in my 0. So I go 4 plus 0 plus 16 over negative 1. So now that I've canceled that out, I won't get a 0 on the bottom. So this is 4 plus 4 over negative 1, which would be negative 8. And that's how you do rationalization. It's the same thing. That would be like number 4 and number 5 in your hand. Okay. If you look at a question like number 8, that's a factoring question. You have to use. You have to take out. If you're looking, it's approaching 3, so you can divide x. X minus 3 can come out of the top and the bottom. So divide x minus 3 out of the top and x minus 3 out of the bottom, and then you would be able to get that. Now we'll get to how you draw rationalization limits. Okay, so if I had something like f of x equals, okay, I won't use x squared minus 16. I'll use something else. Let's say 8 over x squared minus 9. Okay, so what we want to do first of all is we want to factor the bottom. Yes, sir. What's that?
For ambiguous, sign.
Sign. Okay. So in this case, we're going to be factoring the bottom as x plus 3, x minus 3. Okay, so the first thing we want to do is get our vertical asymptote. So our vertical asymptote happens when the bottom is 0. So that means when x plus 3 equals 0 and x minus 3 equals 0. So if we solve this, it's going to be x equal negative 3. And this x equal positive 3. Okay? So that's where our two asymptotes are. That's the first thing we do. To get a horizontal asymptote, we take the limit as x approaches infinity of this. So how do you do it for infinity ones? You divide by the biggest power of x. So that's going to be 8 over x squared. This will be x squared over x squared. This will be 9 over x squared. Okay, now whenever you have these, this is going to be 1. So this is going to be 8 over x squared, 1 minus 9 over x squared. Okay, now these, when something approaches infinity with a variable on the bottom, if you think of it, 8 over 8 billion would be a very, very small number, close to 0. So this becomes a 0, and this becomes a 0. So this is 0 over 1 minus 0, so it equals 0 over 1. So your horizontal asymptote is at 0. Okay, so now that you've got your horizontal asymptote and your vertical asymptote, okay, you would look at the top. There was a variable at the top you could find where the x-intercept is, but there's no variable, so there's no x-intercept. So we're going to draw the graph. So here's my x and y, like this. Y, x. Yes, ma'am. Okay, just put her in one of those there. Yeah, perfect. Okay, and then so what we want to do is draw our vertical asymptotes. So here's negative 3. Here's positive 3. And then our horizontal asymptote is right along y equals 0. So we're going to put a vertical and horizontal asymptote in. It's supposed to be straight. I'm having trouble drawing straight lines. Okay, now what you do here is you got to figure out whether it's going to be here and here, or here and here. So what you do is you just plug in numbers. So I've got 8 over x squared minus 9. So if I plug in a 5, I get 8 over 25 minus 9. That should be 8 over 25 minus 9 is 16, which is equal to 1/2. So at 5, it's at 1/2. So that means it's going to be up here. So that means since it's up there, it's going to curve in this shape up there. Now if I do -5, it's going to be the exact same. So there's going to be one over here. And if we check in the middle, if we put 0 in there, it's 8 over -9. 8 over -9 is about right here. So then it's going to curve like this. Okay, and that's kind of how we do vertical asymptote. That's kind of how we do the rational graphing. Okay. Okay, I'll send you this off, and if you're still kind of stumped, if you're still wondering what's going on, just let me know. Okay, so I will send that off to you here. Just give me, and hopefully that helps out a little bit.